Alright, so in this video, I'm going to be solving the equation x to the power of 3 is equal to x to the power of 5. So, my only variable in this equation is x, so that's what I'm going to be solving for. And now for my solution, I'm going to rewrite my equation down here so I have a little more solving space. So my equation x to the power of 3 is equal to x to the power of 5. And what I'm first going to do is subtract x to the power of 5 on both sides. So then these two cancel out, and I get x to the power of 3 minus x to the power of 5 is equal to 0. Now, from here, x to the power of 5 is the same thing as x to the power of 3 plus 2. And an important property of exponents is that if I have something in the form a to the power of m plus n, this is equal to a to the power of m times a to the power of n. So x to the power of 3 plus 2 is going to equal x to the power of 3 times x to the power of 2. And now I'm going to factor out x to the power of 3. So I get x to the power of 3 times 1 minus x squared. So now this gives me two equations. I get x to the power of 3 is equal to 0, and I get 1 minus x squared is equal to 0. So for x to the power of 3 equals 0, I'm going to take the cube root on both sides. So I get the cube root of x to the power of 3 is equal to the cube root of 0. The cube root of x to the power of 3 is x, and the cube root of 0 is 0. So x equals 0 is one solution. Now for 1 minus x squared equals 0, I'm going to rewrite this as negative x squared plus 1 is equal to 0. And now I'm going to multiply both sides by negative 1. So negative 1 times negative x squared plus 1 is equal to x squared minus 1. And 0 times negative 1 is 0. So I get x squared minus 1 equals 0. And 1 is the same thing as 1 squared. So I have x squared minus 1 squared is equal to 0. And if I have something in the form a squared minus b squared, this is equal to a plus b times a minus b. So this is equal to x plus 1 times x minus 1 is equal to 0, meaning I get two equations, x plus 1 equals 0 and x minus 1 equals 0. For x plus 1 equals 0, I get x equals negative 1. And for x minus 1 equals 0, I get x equals 1. So notice how we have three equations for this equation. Notice how we have three solutions for this equation. Alright, so in this video, I'm going to be solving the equation a to the power of 4 is equal to a minus 1 to the power of 4. So to solve this, my only variable in this equation is a, which is the variable I'm going to be solving for. And now for my solution, I'm going to first rewrite this problem down here so I have a little more solving space. So my problem is a to the power of 4 is equal to a minus 1 to the power of 4. Now from here, I'm going to subtract a minus 1 to the power of 4 on both sides. So then these two cancel out, and I get a to the power of 4 minus a minus 1 to the power of 4 is equal to 0. Now, from here, I'm going to rewrite a to the power of 4 as a to the power of 2 times 2. And I'm going to rewrite a minus 1 to the power of 4 as a minus 1 to the power of 2 times 2. And the reason I did this is because if I have something in the form a to the power of m times n, this is equal to a to the power of m to the power of n. So a to the power of 2 times 2, I can rewrite that as a to the power of 2 to the power of 2. And a minus 1 to the power of 2 times 2, I can do the same thing. I can rewrite this as a minus 1 to the power of 2 to the power of 2, and this is equal to 0. Now, if I have something in the form x squared minus y squared, this is equal to x plus y times x minus y. So, in this case, I can think of x as a squared and y as a minus 1 squared. So by using this property, I get a squared minus a minus 1 squared times a squared plus a minus 1 squared. And this is all equal to 0. Now, we're going to go ahead and expand a minus 1 squared. So a minus 1 squared is the same thing as a minus 1 times a minus 1, which is equal to, I can distribute the a squared minus a. Now if I distribute the negative 1, minus a plus 1, which is equal to a squared minus 2a plus 1. So now I get a squared minus 2a plus 1. And then I have this times a squared plus a squared minus 2a plus 1 is equal to 0. Now for my left-hand side, these two cancel out, and all I'm left with is negative 2a plus 1. And for my right-hand side, these two add, a squared plus a squared, so I get 2a squared minus 2a plus 1, and this is equal to 0. So, now from here, what I'm going to do is divide this into two different equations. So my first equation is negative 2a plus 1 is equal to 0. And my second equation is 2a squared minus 2a plus 1 is equal to 0. Because either of these, just one of these needs to equal to 0 for the entire equation to be equal to 0. So now I'm going to solve each of these equations individually. For negative 2a plus 1 equals 0, all I have to do is add 2a on both sides, and I get 2a is equal to 1. Now, if I divide both sides by 2, these two cancel out, and I get a is equal to 1/2. So this is one solution for a. Now, for 2a squared minus 2a plus 1, what I'm going to be using to solve this is the quadratic formula, because this is a quadratic equation. So the quadratic formula is negative b plus or minus the square root of b squared minus 4ac all over 2a. And in this case, a is 2, b is negative 2, and c is 1. So I plug these values in, I get negative of negative 2 plus or minus the square root of b squared, so negative 2 squared, minus 4 times a, which is 2, times c, which is 1, all over 2a, so 2 times 2. And now this is equal to positive 2 plus or minus the square root of 4 minus 8 over 4, which is equal to 2 plus or minus the square root of negative 4 over 4. So now the square root of negative 4, I can rewrite that as the square root of 4 times the square root of -1. And if you guys already didn't know, the square root of -1 is equal to the imaginary number I. So I get a equals 2 plus or minus the square root of 4i over 4. And the square root of 4 is 2. So I get a equals 2 plus or minus 2i over 4, which simplifies to a equals 1 plus or minus I over 2. So this is another 2 solutions to my equation. And finally, just to check, I can't check the imaginary solutions, but I can check 1/2. So I have a to the power 4 is equal to a minus 1 to the power 4. A is 1/2, so I get 1/2 to the power 4 is equal to -1/2 to the power 4. And both of these equal 1 over 16. So this is right, and my solution is right.